I want to begin by acknowledging my collaborators, Katia, Obraczka, and Colleen Josephson from the School of Engineering, who send their regrets because they are off campus today. So I'm a plant physiological ecologist, which means that I work on how plants work in natural and built environments, such as greenhouses. Now, you might not be aware of it, but there are a number of greenhouses scattered around campus, and most of them are for growing plants for research and for teaching in classes and for having a collection of biodiversity genomic material. These greenhouses are at the Center for Agroecology, and they're actually part of the food system. What happens there is that they plant seeds in trays. They go into these greenhouses until they're big enough to survive the outdoors, and then they're moved out into the fields when they have space for them. And greenhouses are actually part of a collection of technologies known as protected agriculture. And protected agriculture, several examples shown here, provides resilience to climate extremes and typically higher productivity and lots of other benefits. But you can see from the bottom bullet here, there tend to be energy and water intensive. But protected agriculture is widespread. If you think of all of the greenhouses and other type of grow operations you've ever seen in the US, you can see that they're a mere drop in the bucket compared to these other places. And just in the first half of 2022, over $2 billion were invested in protected and indoor agriculture. Here on the UC Santa Cruz campus, we have actually a lot of research interest in agricultural technology, and I was not aware of this level of interest. We had an event last year that drew people from all parts of campus and from all kinds of expertise. Now, I came into this field because on the one hand, in my brand of science, we tend to use greenhouses a lot for growing plants for experiments. And a few years ago, Sue Carter and Glenn Allers invited me to become part of their project on electricity generating greenhouses, which is, some of you may know, has been commercialized in Scotts Valley as soliculture. And my team showed that plants grown under these greenhouses that generate electricity by the sunlight passing through the dye material absorbs the green wavelengths that plants don't use and uses that to generate electricity in thin, tiny solar panels. Compared to greenhouses, typical greenhouses with clear glass, the plants grew the exact same, and some of them, in fact, had photosynthesis levels that were more efficient than in the clear glass houses. Now, our collaboration with Katia and Colleen has taken us to a new level of technologies in greenhouses that I want to describe here. And greenhouses often contain supplemental lighting, as you can see here, to help on cloudy days or on foggy days here, or in northerly climes on shorter days during the wintertime. A lot of energy also goes into heating and cooling greenhouses, depending on where they're located. A lot of water is used for irrigating. More and more, the supplemental lighting is done by light-emitting diodes, and usually these lights are actually a bank of many, many individual diodes. If you take one of those diodes and you flash it on and off, it's like zeros and ones, and it becomes a digital signal. If we have a computerized control board down below that measures things like temperature and light and humidity and maybe how much water is in the soil of the pots, and with a little solar panel built into that, we can see that flashing light, and that becomes a communications channel that we call Li-Fi. It's a parallel channel to Wi-Fi, and it provides a way to communicate with that board. And then if we take the data, temperature, humidity, and so on, and then we use Wi-Fi to collect that data, and then we are basing this system on the hardware and software of the Internet of Things. Now, the Internet of Things, hardware and software, is what underlies the Ring doorbell, the Roomba vacuum, and your Alexa countertop assistant. The hardware and software can be used to collect data. we've used this down at the Coastal Science Campus to show that temperatures were different in one of the experiments down there. The greenhouse managers were able to coat the greenhouse and brought out the temperature disparity. So our plan is to use this Li-Fi system and actually ask the plants to contribute data. We can point sensors at the plant that help the control loop of temperature, turning on or off lights, warming it up, cooling it down. We can ask the plants, would you like a drink, rather than measuring the soil. And so the system becomes much more responsive. It's online. You can see the data anywhere. And we're also concerned about how much water is used in these greenhouses. And I was just down there for a couple hours today, crawling around under there, putting sensors to determine how much water is being used in these spray systems. And we have a vision for powering the Center for Agroecology using this emerging dual-use technology of agrivoltaics, where you put solar panels on top of farm fields, and they actually have a synergism where the plants appreciate the shade, and the solar panels work more efficiently when they're cooled from below by the water loss of the plants. We actually have a vision to create the world's smartest greenhouse. And I'm getting the signal to stop, and I'm just going to show these, and thank you for listening, and we'll be happy to take any questions.